Today, basically what we're going to be taking a look at is the base image of the base parabola. And we're going to hopefully understand what steps mean. When we're talking about stretches and of parabolas, and we'll also take a look at translations of parabolas up and down and right and left. Now, how do we know we understand this? You'll be able to look at an equation and then immediately tell me whether it's moving left, right, up or down, or the graph is stretched or compressed. And also whether it's opening up or down. All right, so let's talk about the basic image of the parabola y equals x squared. So when you take a look at this parabola, the original parabola is y equals x squared. So we're going to use these points and we're going to plug them in. So technically what you do is you take x is -3, plug it in to here, and you'd say, well, if x is -3, then our equation looks like this, which gives us y is equal to 9. And now you do the same for 2 and 1, and you would end up with something that looks like this. 9, 4, and 1. So you get -3, 9, -2, 4, -1, 1, and 0, 0, 1, 4, 9, and 16. Now, for this lesson, we're going to cut out all of the calculations that we would normally do by hand, and we're going to use Desmos for that. But first, let's go and graph this. So you're going to take these points and graph it onto this base image chart, and you would see something that looks like this. So now you'd have your points that look like this, and now let's graph it. Connect all the points. To save time, we'll use Desmos to create our information for our table. So I want you to change this from x1 to x, and the y values for it are going to be x squared. So imagine that we start from -3, we get 9, and then -2, and -1, and when we hit enter for the rest of these, you're going to get the rest of the points for our graph, and you'll see that our graph shows up here, right? Now, this is what we get. And when we graph it, we should have something that looks like this. Y is equal to x squared, and we get something that's similar to this. Now, let's go take a look at our graph and see if there's anything that we notice about said graph. So once we've got our graph loaded up like this, one of the things that we're going to do is we're literally going to take a look at the differences, at the first differences of each y value. But what we're going to do is we're going to look at what their differences are in relation to the vertex, which is at this point 0, 0. Now, with respect to its height, if I take a look from here to here, this is 1. The difference between this point here and that point is actually, well, 1, 2, 3. And the distance between this point and that point, that was horrible, is 5. So based on where the vertex is, each time we go over 1, we must go up 1 from the first point. Then if we go over 1, we must go up 3. And then if we go over 1 again, we must go up 5 based on y equals x squared. So we would say that our steps for this thing are 1, 3, and 5. And what that does is it allows us to quickly graph our parabola from the center point, otherwise known as the vertex, for all the other points on the graph very quickly. So for the vertex, we go over 1, up 1. Then we go over 1, up 3. 1, 2, 3. Then we go over 1, up 1, 2, 3, 4, 5. And we're good to go. So anytime we know what our vertex is, we should be able to quickly graph it. Now this is something that we will use not in this lesson, but the next lesson. So I'll have you take a look at this later. Now let's go on to the lesson. For these questions, you're going to have to use Desmos to generate each one of the points within the table. So let us use this graph. Each point on this graph, each cube on this graph is worth 1. So from before, we had this for y equals x squared. Now, take a moment and graph those points on your chart to the right here. And you'll see our graph looks like this. Okay? So remember, make sure you label your graph as well. And we have y equals x squared. Now what we'll do is we'll go back to our Desmos app and we will generate y equals 2x squared, and we'll see what the x values are. I meant y values. So in order to generate the new set of points for y equals 2x squared, we have to click to the right of the x squared and we just write 2x squared. And what it does is it generates those points. And you'll notice that the points are going to kind of look like this. So what I want you to do is copy these points into your chart. Pause the video and copy those values for 2x squared into. So you'll notice that when you take a look at 2x squared, essentially what's happened is we've literally taken all of the y values and times them by 2 to get to our 2x squared value. So something's going to happen to our y value. So now let's go and graph it. Sorry, I meant y values. So let's see what happened. So now you'll notice when you plot those points, those new points that we calculated end up being, it seems to that means the vertex stays the same, but all of the points shift up by a factor of 2. And now this is our graph. Connecting the dots, we have something that's similar to this. So it's kind of like what's happened is we have literally stretched our parabola, like by pulling it straight up, pull up each of the points by a factor of 2. So now let's go and take a look at y equals 3x squared. Try to graph the points and predict what will happen. So when we go to revisit Desmos to quickly graph this, what you should have for your third set of points is something that looks like this. Remember, go to the right of 2x squared and right now 3x squared. And you'll see that the points are stretched again. And those are the points. What I want you to do is I want you to put those points on your graph, please. Thank you. Pause the video. And we'll graph those points. And when you're done plotting your points, you're going to have something that looks like this. And we end up with y is equal to 3x squared. So what is the role of this, of ax squared? If a is greater than 1, then the graph is skinny. And what we do is we call this stretched. This is the mathematical term, stretched by factor of whatever value is sitting in front of our term. So if it was 2x squared, we would say that this is stretched by a factor of 2. If it was 3x squared, we would say that this is stretched by a factor of 3. So now what I'd like you to do is I would like you to move on to this next problem here. And what I'd like you to do is I would like you to plug those points in and see what our values are going to be. Okay? Good luck. Pause the video, and I will do this section in the next video.